Hi, and welcome to Miss B's After School Hours with our online classroom. And what we're going to be doing today is we're going to be talking about volume. So before we talked about surface area, and I had a cylinder here, and I'd say, okay, what's the area of this? What's the area of my bottom? And then what is the area to cover the rectangle that makes up this cylinder? Today we're going to say, okay, what does it take to fill up my container here? Because depending on the heights, or if it's a prism, the lengths, the widths, our shapes, while they can be similar, can hold different amounts of volumes. So let's take a look at that today. So the first thing we're going to talk about is a volume of a rectangular prism. Okay, so basically a 3D figure that is a rectangle. So we know that volume is the area of the base times our height. Okay, so with a rectangle, it's the area of the base. Well, the area of the base, this right here, is length times width. So when we add the height, it's times height. So our formula for volume is length times the width times the height. So when I have my rectangular prism, and sorry, Miss B is not the quickest straller, I'm going to do my length times my width, how wide is it, times my height to figure it out. And I'm sorry, let me move this so you get more of the board. All right. Next is our volume of a triangular prism. All right. So we also have the volume now, this is basically a 3D triangle. How much can it hold? Again, it's going to be volume is the area of the base times the height. Okay, so when I'm looking at this here, I have to think of, well, what is the area of the base? What is the area of a triangle? That's why we did our warm-up yesterday, which had us find that. And the area of a base is 1/2 times base, okay, times height of the triangle, which we could kind of rewrite as width so that we don't get confused because we're going to have another times the height. So when we write the volume equation for this, we usually say area of the base with a big B. So we know it's 1/2 base times height times the height of the prism. So it's a little confusing because in order to find the area of the base, we also have like a height, kind of like in a rectangular. We have a length times height, but we have the other word width. Here, we don't, so we have h times h, and it's not h squared because they're going to be different heights. So if you wanted to, you could kind of write this as a W. So 1/2 times the base times the width times the height, and that would give you the same thing. I hope that makes sense. All right, now the last one is going to be the volume, excuse me, I need a tissue, of a cylinder. Okay, so this kind of figure right here. All right, so if I erase my board, all right, we know that a cylinder looks like this. So we want the volume of a cylinder, and this is probably one you're going to come across a lot, and it's going to be handy to know that and rectangular prisms in our everyday life because, you know, comparing cereals, which are rectangular prisms. That's something, anything that comes in a box. If I were to move something, how much can I fit in? Whereas the cylinder in the grocery store, it's our canned goods. It's going to be kind of like our drinks sometimes. How much can we fit in there? So these are important real life things to know. So again, the volume is the area of the base, and it's times the height. So now we have to look at, okay, what's the area of our base? Well, we know for that, the area of our base, it's going to be pi r squared, because that covers the circular part of our cylinder, okay, because the area here is pi r squared. But we also have the height to include as well. All right, so the volume of this is going to be this amount times the height, and that will figure out our volume. All right, so let's kind of define volume real quick. Volume, what is it? So the volume is of a three-dimensional figure is the number of cubic units needed to fill the space inside a figure. All right, and you'll come across this a lot in science class. Remember, volume is always going to be like meters squared, inches squared, centimeters squared, liters squared, or cubed, which is just 3 times that, because we have 3 types of measurements going on usually. So our length times width times height for a rectangular prism, well, there are 3 measurements, so therefore it's going to be cubed. That's what I tell my students who are in 8th grade, who deal a lot with finding the volume and the density and, well, not density, but who are dealing with finding those measurements. Okay. So, and then a cubic unit is a unit, or is a cube with edges 1 unit long. Okay, so if you think about my Rubik's Cube, which is a cube, all right, so I have my Rubik's Cube, all right, at school that everyone likes to play with. It is a 3 by 3 figure. So what they're saying here is that when we have a cube unit is the one where it's a 1 by 1, okay? It's 1 in its height and it's 1 in its width. So that's what a cubic unit would be like. All right, so let's take a look at some examples then. All right, and I'm going to come up here. Let me erase this. So the first one says, find the volume of a rectangular prism. So we have to look at, okay, what are going to be our dimensions? So they give us a box, or a rectangle, I'm sorry. Come on, Miss B, use the correct terminology, that they said has a 12 centimeter, it's got a height of 10 centimeters, and, oh, hang on. Let me draw it so it matches more like the picture. All right. Okay. I don't know if that changed all that much, but it's got 10 centimeters in height. Okay. The length is 8 centimeters and the width of it is 12 centimeters. So they want to know what is the volume. Now remember, volume is always going to be the base the area of the base times the height, or in this case, volume equals length times width times height. So I'm going to go ahead and I'm going to do V equals 12 times 8 times 10. When I plug that into my calculator, I get, pausing so you can do it, I get 960. Now, I can't just leave it as 960. I have to look at my units. My units are centimeters, so I'm going to write V equals 960 centimeters cubed. Okay, I hope that makes sense. All right, so let's take a look at a rectangular prism or a triangular prism. Now this one's a little harder to draw, so be patient with Miss B's drawing skills. Kind of looks like a big block of cheese. That's what I'm kind of imagining. All right, so here's our triangular prism. Now it's 3D. So we're given that this is 7.5 inches and that this here is 10 inches. All right, then we're given that our diagonal is, I need to draw my line down here. This would be easier if I had moved. Is 12.5 inches, and then this is 10 inches as well. All right, so how am I going to do this? Well, I have to first find the area of the base, which would be this one here. All right, so that's going to be 1/2 times 7.5 times 10. All right, so we're going to find that. So that equals 37.5. That only deals with this here. I have to then multiply it by the height. So I'm going to do 37.5 and I'm going to multiply it by 10 since that's our height here. When I do that, I get 375, and then don't forget your inches cubed for the volume. Now you're probably going, wait a minute, Miss B, you didn't use the 12.5 inches. You're right, I didn't use it, but it wasn't necessary. Sometimes they're going to throw in that here. That is our diagonal. That's not important. It would be important if I was using the Pythagorean theorem where I needed to know all 3 lengths of the triangle, but it's not important, so we just ignore this unit. Just because they give it to us doesn't mean we need to use it. And that's something that in future PSSAs you want to make sure. Know your stuff, know what you do and do not need to use. Alright, so this is going to be the conclusion of video 1. I want you to hop on to video 2 to see the volume of a cylinder.